Oh, change of scenery. Science lab. Dead guy in the back. I can't even point that there over there. All right. We're gonna keep going with domain and range on the same part we were working with sign diagrams. Domain is just the x values. It's the set of x values in the relation. Just domain is all of the stuff you can legally put into the equation, and the range is all the stuff that you possibly would get out if you put those legal x values in. So, for example, if you have like y equals x plus 3, is there any restrictions on what you can put in for the x? Can you put in really big numbers? Yeah. Really small numbers? Yeah. Decimals? Yeah. 0? Yeah. It's not a big deal. You'll get out anything. You could get out fractions and decimals, depending on what if you put a half in, you'll get 3.5 out, and you'll get fractions and decimals. So domain of this is anything, all real numbers, which we denote like this, R with a double backbone. And what'll come out is all real numbers also. We'll talk about the specifics, but how you show that is this way. You'd say my domain for this function. It looks like I can get, domain is my x's, so it looks like I can get x's at the smallest are -1, and then they increase from there, right? So that's why they're saying the domain is x's such that x's are greater than or equal to -1. It's a closed-in dot, so that's this piece, right? Likewise, the y's bottom out at -3 and then go up from there. So the range is everything that I can get out is the range is this, right? Is y's bigger than or equal to -3. Now, this isn't this. I was just giving an example. Let's see what's hiding over here. Oh, okay. Here's a couple more examples about domain and range. Let's clear that out of there. This is a quadratic, and so the domain, just looking at this, I don't know what the function is, but the domain, if I walk along this line and look down, there's always a graph under me. So like, is there any limit to how far over this way or over that way you can go? Nah. And so that's why the domain is anything, all real numbers, right? It can be anything. You can put in any x value and you'll get out a y value. But because of how the quadratics work, just like the boxes, they top off at a certain point and then fall down. So it looks like the maximum y value that I'll get is 1, and then everything's below there from there. So the range is y's such that y is less than or equal to 1. I'm just reading that off the graph. Same thing with this hyperbola. Looks like if I go really far this way, really big numbers are fine, really big negative numbers are fine, but something happens right here, and we'll talk about that tomorrow, and it looks like there's this asymptotic behavior at 2, x equals 2. So domain is everything, but x can't be 2, and the range, it looks like as we go this way, my value approaches this x equals, or y equals 1, and it approaches on this side as we go to infinity also, but never hits 1, so it looks like y can't be 1, right? So domain and range is just what goes in, what can come out. Yeah, there's a couple of problems with some functions. So like x squared, you can really put anything in for x, right? Really big numbers, if you put 1 billion in and square it, that's fine. You can put in -1,000,000 and it's fine. You could put in 0, you can put in negatives, fractions. That's no problem. So the domain is the natural, like the domain what can go in is anything. That's a problem with square roots though, right? Because you take the square root of 25 and you get 5, because 5 times itself also gives you 25. So the square root of 25 is 5, but also -5 times itself gives you 25. So the square root of 25 is both plus and minus 5. That comes into play when you try to take the square root of a negative, right? Square root of -25 is not a real number. They're imaginary numbers. Yes, they exist. No, we're not going to talk about them. It's I, if you're interested in looking up I. I is the square root of -1. Bigger story. But This doesn't really exist. We can't really take the square root of a negative because it doesn't give you a real answer. It doesn't give you -5, it doesn't give you +5, it gives you 5i, which is unreal. So really, the things that we can put in have to be bigger than 0 or equal to 0. The square root of 0 is 0 because 0 times 0 is 0. So we can't or shouldn't put in negatives into the square root, and that's reflected in the domain. The domain of a square root is numbers bigger than or equal to 0. Same thing if you have a rational function, a fraction. Ratio means divide, so a rational function is one with a big division in it. So if you have something like 1 over x, you can divide 1 by -10, that's fine. It gives you a small negative number. You can divide 1 by 1,000, that's fine. But and you can divide 1 by a fraction. You could say 1 divided by a half. You'd invert and multiply. This ends up giving you 2. Not a big deal. Sorry about my typing. I'm doing using a trackpad. What you can't put in the denominator is 0. Right? It's because I can take 0 pizzas and divide them among my 5 friends. It's unfortunate, especially before lunch, but it's not a weird answer. It's 0, right? 0 pizzas given to my 5 friends. But I can't take 5 pizzas and put them nowhere, right? Like, you can take 6 and divide by 2. It means you take 6 things and put them in 2 piles, 3 things in each pile. You can take 6 and divide by 3, means take 6 things and divide them into 3 piles, right? 2 in each pile. But you can't take 6 things and put them nowhere, right? That's what 6 divided by 0 is saying. That's undefined, an undefined solution. So I don't want 0 in this denominator, long story short. So the domain is anything but no 0 in the denominator. And then if you have a square root and a rational, it's the same thing, but it can't be, the x has to be 0. It can't be 0 because it's in the denominator, and it can't be a negative because it's in the square root. So you get a little combination of both. So we'll try to, your head out of the way, Gorkevich. We'll try to find the domain and range for these. Here's square root of -5. I know that whatever's inside this square root, let me get rid of this thing. Whatever's in this side of the square root can't be negative because it's in a square root. We can't take the square root of a negative. So I know that whatever goes in, x minus 5 has to be bigger than 0. It can be equal to 0 because square root of 0 is 0. That's fine. So if you solve, you say, oh, x has to be greater than 5. And if you graph that, so this is the domain. Right? Domain is the set of all real numbers, of numbers, such that this is happening. I won't write the whole thing out because I'm writing with my finger. If you graph this, you'd see that you get a intersection at 5 and values that way, but no values this way, precisely for this reason. You can't put these numbers in because they make the radicand, the stuff inside the square root, negative. So like a 2, if you put a 2 in there, you'd get -3, and you can't take the square root of a negative. Cool? Same thing with this. I want this denominator to be whatever's in this bottom. I want that to be bigger than 0. But it can't be equal to 0 because it's in the denominator. So we set it like that. Oh, this could be like that because this 5 is fine. You could put 5 in here. You go 5 minus 5, 0, square root of 0, 0. So the 5's okay. But here we want x to be greater than 0, but not actually equal to 0. Oh, sorry, 5. What's wrong with you, Gorkevich? Greater than 5. And if you graphed it, you could see that all the x values are over here, and it approaches this limit asymptotically. We'll talk about what that means tomorrow, but never actually touches. Right? So this makes sense. So there's your domains. The ranges of these are what comes out. So if we graphed this, let's just do it graphically, I suppose. If you put in 5 into this, you put it in like our smallest value, what would come out of here? Well, if we put 5 in here, you get 5 minus 5 is 0, square root of 0 is 0, so the y value associated with this smallest value is 0, and everything else is bigger than that. If you're not sure, try a value. Try 30. If we put 30 in there, you'd go 30 minus 5 is 25, square root of 25 is positive 5, so it'd be up here. So everything up here would be positive. So it looks like the range would be y's, all of the y's that are bigger than or equal to 0. Yeah, because this one's right at 0. This, it looks like, just looking at the graph, looks like the y values are, this really gets close to the x-axis but never touches it. So I think the y's are bigger than or equal to 0. And here the y values go up and up and up forever and don't stop. Right? So domain and range. Cool? Give that a shot. There's 2 parts to the home learning ones, the sign diagrams, and you're going to do sign diagrams. There's another one that's domain and range. Stop when you get to piecewise functions. Cool? Bye. Make it stop.